Good morning, Prep 3 students. How are you? I am your math teacher, Ahmed Faiz. Let's start our lesson today, which is the relation between the inscribed and central angle subtended by the same arc. Okay, first of all, we have to know what is the inscribed angle and what is the central angle. The inscribed angle in this figure, the inscribed angle is the angle whose vertex lies on the circle, lies on a point of the circle, not inside the circle or outside the circle. It's on the circle. So as we notice that B is the vertex of the angle and it lies on the circle. Okay, so ABC is an inscribed angle. Okay, what is the central angle? The central angle is the same angle, but the point of vertex is not on the circle. It's inside the circle, but not inside the circle in any place. No, it's in the center. So here, BMD is the central angle. If we have a point here, it's not a central angle. Here, it's not a central angle. Here, it's not a central angle. Only in the center, in the point of the center, this is called a central angle. Okay. In the first figure, look at the arc opposite to the vertex B. It's the arc AC. So the inscribed angle ABC is subtended by the arc AC. It's looking for the arc AC. Okay. And in the other figure, measure angle BMD, which is the central angle, is subtended by the arc DB. So the arc DB is the opposite arc to the angle DMB, which is the central angle. Okay, in the same figure is measure angle BAD. Is an inscribed angle? Yes, it's an inscribed angle. Okay. Why? It's an inscribed angle because its vertex lies on the circle. Okay. Notice that here measure or the angle BAD, which is the inscribed angle, subtended by the arc DB, and the central angle BMD, subtended by the same arc DB. So the central angle and the inscribed angle are subtended by the same arc DB. What that means to me? If the two angles are subtended by the same arc, here I can guess that the inscribed angle is half the measure of the central angle. So if the central angle is 100 degrees, so the inscribed angle will be 50 degrees. And the measure of the arc DB, which is subtended by the two angles, is equals to the measure of the central angle and twice the measure of the inscribed angle. So now we have to know that the measure of the arc, which is the inscribed and the central angle subtended by it, is equal to the measure of the central angle. And the inscribed angle is half the measure of the central angle and half the measure of the arc. Okay? Let's take an example to know how to solve questions on this. Here, in each of the following figures, find the measure of the angle denoted by the sign question mark, given that M is the center of the circle. Okay. In the first figure, you want me to find the inscribed angle ABC. Okay. To know the measure of the inscribed angle, I have to find the measure of the central angle or the measure of the arc. Okay. The central angle here is AMC. Okay. How can I find the measure of the central angle AMC? Look here. We have a small triangle called MAC. And he give me the measure of the angle MAC, which is 30 degrees. What can I do with this 30 degrees? As we know, MA and MC are two radii in the circle M. And we know that any number of radii in one circle are equal in length. So MA is equals to MC. What that means? That means we have here an isosceles triangle. We know that the isosceles triangle is the triangle which has two sides equal in length. So here, MA equal MC. And the properties of the isosceles triangle is when we have two sides equal in length, so we have two angles equal in length. Okay. MA is equal MC, so measure angle A equal measure angle C. So measure angle C here in this triangle is 30 degrees as the measure of the angle A. Okay. As we studied before, that the sum of measures of the interior angles of a triangle equals what? Equals 180. The sum of the three angles of any triangle must be 180 degrees. So now I have the measure of two angles. Can I find the third angle? Yes. 180 minus the sum of the other two angles. The sum of the two angles are 30 plus 30 equals 60. So the measure of as a central angle AMC is 180 minus 120. 180 minus 60 equals 120. So the central angle now 120. Now I can find the measure of the inscribed angle ABC. Because as we know, if the inscribed angle and the central angle are subtended by the same arc, so the measure of the inscribed angle is half the measure of the central angle. The central angle is 120, so the measure of the inscribed angle is 6. Is that clear? Okay, let's go to figure 2. Figure 2, I have a central angle AMC, which is 140, and he wants me to find the measure of the inscribed angle ABC. Okay, before I say the inscribed angle is half the measure of the central angle, I have to find the subtended arc by the two angles. Must be subtended by the same arc. Okay. Is the measure of angle AMC is subtended by the arc which is angle ABC subtended by it? ABC subtended by the arc AC, this AC, the major arc, the greatest arc. Okay. And AMC subtended by the same arc? No, it's subtended by the arc AC, but the opposite arc AC. Okay. So they are not subtended by the same arc. So what can I do now? I have to find this angle. which is the reflex of the central angle, because this angle is subtended by the arc AC. So it will be subtended by the same arc, which is the inscribed angle subtended by it. Okay. So the reflex angle, I can get the reflex angle as we know and as we studied before, 360 minus the angle. 360 minus 140, it's 220. So this angle is of measure 220. Okay. Now, this is the central angle, which I will get the inscribed angle from it. So the inscribed angle ABC is half the central angle AMC, which is the reflex of the angle AMC. Because we know that the reflex angle is between 180 degrees and 360 degrees. And the number 220 is between 180 and 360. So the reflex angle AMC, which is the central angle also, is subtended by the same arc of the inscribed angle ABC. So ABC now, measure angle ABC is equal half the measure of the reflex angle AMC equals 110. Now this is the end of our lesson. Thank you for your listening and see you next session.